Hello, welcome to this lesson of our study of integral equations. Okay, so if you have not subscribed to my channel, kindly subscribe to support the channel as well. Okay, all right. In this lesson, we'll go through what we call numerical quadrature. Okay, so it's very lengthy, but it is also a method of solving, or one of the methods of solving Fredholm's integral equation. Okay, so this method uses numerical approach. Okay, so let's start now. Given y of x being equal to f of x plus lambda integral from a to b, the general form of the Fredholm's integral equation, like this one. Okay, with k of xt, that's the kernel being separable, then we know that our y of x is being, or can be written as this. Okay, in effect, the last one. Okay, y of x equals f of x plus lambda g of x. This, we know this. Okay, we've had a video on the various kernels and their definitions. So if you don't understand any of these, or how I've separated them like g of s, h of t, you can watch that video as well and then understand it. Okay, I'll actually leave it in the comment section, so just check it out. Okay, so now, but we know that, okay, so we've gotten something like this. Okay, at the end. Okay, so you realize that under the integrals, and you have only functions of t, and you're integrating with respect to t. So what this means is that from numerical integrations, we know that the integral of a function f of x dx from x naught to xn can be rewritten as summations of these. Okay, I hope you get this. So it's equal lambda summation from I starting from 0 to n alpha I, okay, f of xi delta xi. Now this means that h of t, the integral of a to b h of t y of t, this side in the integral equation, can then be rewritten as summation alpha j. Okay, we are using j here, then whatever that is under the integral sign. Okay, so hj of tj, yj of tj. I just chose to write it yj because there is no space here. Okay, then times delta t, since we are integrating with respect to t. Here we're integrating with respect to x, that is why we had delta x. Okay, and so this one, so when you come to t, you have to get delta t. And if I substitute this part, okay, for the integral a to b h of t y of t dt, that will be written as a summation inside the integral equation, then the solution of the integral equation will then be given by y of x equals f of x, okay, plus lambda g of x, then a summation of that. Okay, so now our main task here is to go and find yj's, the yj's. Okay, so from here we know everything, and also look for the delta t and alpha j, and that will be all. Okay, you know h of t, so it will be given as part of the kernel, so our aj of tj will then be easy for us. Okay, so the yj's are given by, so this yj that I was talking about is the same formula. This same formula, we'll use it for the yj, but here we'll also consider the x changing. So if you remember, in the first one, this equation, okay, in this equation, for the solution of the integral equation, realize that only the j's were changing, that summation of that. Now when you want to find the yj's, you write the same formula, then you also consider the x is changing. Okay, so here we have yi, so we'll use I for the x. Okay, so you have yi here, okay, equals fi of xi plus lambda gi of si, then you write everything back again. Okay, we've already talked about this. Okay, so you use this method to find your y's, so that you come and put them back in after finding your y's, you come and put them back here wherever I see yj, you put it here to simplify the sum here, and then you get your solution. Okay, so it's a 2-in-1 problem. So from f of x we can get fi of xi, and same or likewise to g of x and h of t's. Okay, now the question someone may ask is, what is my delta t and what is my alpha j? Okay, So these are from the various rules of numerical integrations. Okay, so with the various rules, let's remind ourselves of some of the rules. The first one is the trapezium rule. Okay, so the trapezium rule is how the formula is being given. So the alpha j's are just the coefficient of the fx. Fx is inside here. So here the coefficient of f of x naught is just 1. Here we just have 1 multiplying it, and of all the f of x2, s3, f of x1 and the rest, their coefficient is 2. Then the coefficient of f of xn, that is the n that you talk about here when n is equal to 2. Okay, what will happen is that it will start from n equals 0, 1, then 2. Okay, so it means that for my alpha will be equal to, when you come to n equals 0, I have f of x naught, so I have 1. N equals 1, I have f of x1 and I have 2. Okay, but when n equals 2, that is the last one for our n. Okay, that is the last one for our n, so it means we'll come back to f of x2 and that one will give us 1. I hope you understood this. Although somebody may think that okay, it's f of x2 and then you're supposed to get 2 because f of x2 will happen here. No, this is because we said it from f of x naught to f of xn, and so your n will be the last one. So the last one here is x2. We said n is starting from 0 to 1, 2. Okay, so 0, 1, 2. So it means that f of xn here will be f of x2, and then the coefficient there is also 1 here. Okay, I hope you understood this. So let's say if n is equal to 5, okay, then with the first one, n equals 0, you get the coefficient to be 1. N equals 2, 1, the coefficient is 2. N equals 3, the coefficient is 2. N equals 2, coefficient is 2. N equals 4, coefficient is 2. But when n is equal to 5, that is the last one, then the coefficient will be 1. I hope you get it. So the alphas in the trapezium room are just these. So when you are asked, or when you are being asked to find the solution to a certain integral equation using numerical quadrature with trapezium rule, then you know how you find your weights or your alpha j's. Okay, now the delta t is also given by just the front here, the front the variable here, or the term in the front here. Okay, so half h. Okay, where you know your h in all cases is b minus a, okay, over n. So the number of nodal points that will be given, that is the n, then you use it to find your h. Okay, I hope you get this. Now you know that the trapezium rule actually works for all possible n's. Okay, so it can work for even n, and it can also work for odd n's. Okay, now Simpson's 1/3 rule. So with the Simpson's 1/3 rule, is also a rule in numerical integration, and then the delta t for that one specifically is given as 1/3 h, and the alpha j from this formula, the coefficients are these. Okay, so here when you have n is equal to, so you said that this works for even Simpson's 1/3 rule. I think here there is a problem here. Here shouldn't be 3, it's n minus 1 rather, I think so. Okay, so with this, okay, what happened is that when n is equal to, let's say it's even. Okay, so when n is equal to 2, then it means that we have n equals 0, 1 and 2. So it means the x naught will be 0 and the coefficient of that will be just this, okay, 1. And then x1 is found here in the odd numbers of i's. Okay, so it means that for x1 the coefficient will be 4. Now when it comes to 2 is the last one. That will be the f of xn. Here the f of xn here means the last one. Okay, so 2 will be the last one because n starts from 0 to 2. So it means that the coefficient of f of x2 will just be 1. So for n equals 2 in Simpson's 1/3, 2 wouldn't be part of the weights, the alpha j's. Okay, I hope you get my points. Okay, so just take it. That is what's really the step as law of students. Okay, I hope you get this. All right, so with this one, note this works for even numbers of n, that is n equals 2, 4, 6, and the rest. So when n equals 4, let's say 4, it means my n start from 0, or my I will start from, let me put it that way. My I will start from 0, okay? I will start from 0 to, so 1, 2, 3, then 4. Okay, remember 4 is the last one, so the coefficient or the alpha naught here in n equals 4, alpha naught has a weight of this side, okay, the f of xn or s naught, and that is 1. Alpha 1, the I1 is inside this side or is here, okay, so it means that alpha 1 will be equal to what? 4. Now alpha 2, you come back to where I has a 2. Alpha 2 will be the coefficient here, 2. And then alpha 3, then you come back to where the 3 is. So the coefficient for alpha 3 will be equal to 4. Now when you come to alpha 4, that is the last one. So it will be 1. I hope you get this point. Okay, so that is for the alphas. Okay. I hope this explains the alphas very, very well for you. And I believe you know the delta. The delta t is always simple. So with the Simpson 3/8, that one too, delta t is given as this, okay, 3/8h, and n is a multiple of 3. So for this formula to work, n should be a multiple of 3, and the coefficients are d. So use that same analysis for finding the alphas, okay. And with this shows that for all the various values or the various rules in numerical integration, all the alpha n's are 1 and alpha naught is also 1, okay. So it means that here, if n is equal to, let's say, 3, multiple of 3, okay, then you start from n equals or I equals, let me put it that way, I equals 0, 1, 2, and 3, right? So when I equals 3, alpha naught will be the coefficient. Sorry, I equals 0. Alpha naught will be the coefficient of f of x naught, and that is 1. So we pick this. And when I equals 1, where is 1? 1 is located here. Okay. So the coefficient will come and pick alpha 1 to be 3. And when I equals 2, 2 is also located here. So we come and pick 3 as well, because that one too, it has 3. Now when I equals 3, that is the last one. So you don't come to this one, you go to the last one, okay? I hope you get this. I equals, you said n equals 3, that is the last one. So f of x3, and the coefficient there will be 1. So when n equals 3, you have alpha naught being equal to 1, alpha 1 being equal to 3, alpha 2 being equal to 3, and alpha 3 being equal to 1. That is the last one, okay? So I hope you understand this. So if let's say n equals 6, okay, then alpha naught, so you have I being equal to 0, 1, 2, 3, 4, 5, and 6, okay? So alpha naught will just be 1, alpha 1 will be 3, alpha 2 will be 3, alpha 3, so you come to this side, okay, and that will be 2. Alpha 4, so you go to where 4 is here, it will be 3. Alpha 5, you go to where 5 is here, it will be 3 as well. Then alpha 6 is the last one, so you come and pick 1, okay? I hope you get this. So that is it. Now h is equal to, like I said, in all cases, b minus a over n. A and b are integral limits, and then the n is the number of nodal points given. So now record that when you are having an integral equation of this form, then the solution is this, okay? Now we have some yj's in our solution. So to find your y's, come and use this formula, okay? And you know how to find your delta t and alpha j's. Okay, so let's go ahead and pick an example and start with example, and then you understand very, very well, okay? So solve the Fredholm's integral equation y of x equals this. We've been solving this same question using different methods, okay? So x squared minus integral from 0 to 1 x t y of t dt, okay? Using numerical quadrature with Simpson's 1/3 rule. So here We are using Simpson's one-third rule though, but then they didn't give us n. So we said that Simpson's one-third rule works for n being even. So let's choose n to be equal to 2. I don't want to work very or work with a tedious number, because when n equals 4, meaning that I'll be looking for y naught up to y4, which will be 5 unknowns, and I don't want that. But when n equals 2, I have 3 unknowns, and that will be cool with me. Okay, so we pick that example, and like I said, we start. So from this, y of x equals s squared minus that, we have our lambda to be equals -1, our k of xt to be xt, and meaning this can be written as g of x times h of t, meaning that g of s is x, h of t is t, and my f of x in this question is what? S squared. You know all these well. Then let's go to the formula. We said that Simpson's one-third, right? So the Simpson's one-third is given by this. So we should know this, okay, and that, plus f of xn. Now you know that delta t is also given by this, where my h is this, and my alphas are just 1, 4, 2, 1. Okay, this means that I should just know where my alphas will be and what alpha should I pick. Okay, now from this question, f of s, like I've written earlier, is this, k of xt is this, g of s is that, and h of t is actually t. Okay, so choose n equals 2. Then this means that our h is equal to 1 minus 0, which is the integral limit, equals over 2, which is equal to half, and meaning that delta t would then be equal to 1 over 3 times half. Okay, so 1 over 3 times half, and that will give me 1 over 6. This is it. Okay, so we have, you see, this is very simple, just that when you don't know what to do, then that will become a problem. When you know the formulas you should use for each term, then you are cool. Now with the xn, okay, so you see that we have some xi's in finding the y's. Okay, to find the y's, where is the formula I wrote? Okay, so to find we have some xi's here, okay, and then some tj's. Okay, so it means that we have to go and then find the corresponding xi and tj's. Okay, so the xn, here is supposed to be xi rather. Okay, here is supposed, and then t is supposed to be tj. Okay, so xi and tj. So this means that x naught, so n equals 2, meaning that I will be equal to what? Or I will start from 0, 1, and 2. Okay, so s naught will be 0. We are just calibrating the limits from 0 to 1. Okay, so we know that the step size, or the h, is supposed to be half. So when I start from 0, then I add half to it. Okay, and that will give me half. That will be my x1. So s naught is 0, adding half to 0 will give me half, and adding half to half will give me 1. I hope this is cool. So this means that these are my specific i's. Okay, xi's. X naught is that, x1 is that. So we come to the tj's. Okay, t naught is 0 from the same limits. Okay, then we add half to 0, you get half, and then you add half to half, you get 1. I hope you get this. Now from this, we said our solution is given by y of x equals f of x plus lambda g of x, then summation this. Okay, that is our solution. Now we know delta t, we know h of t, meaning that hj is equal to tj. Then we know our g of x, we know our delta t, and we know f of x. So we come and put them here and realize that this is your solution. So the only thing we need to go and find is our yj's, because our alpha j's, we know them from Simpson's one-third rule. Our tj's, we also know them as well, because the t naught is here. So when j equals 0, I have t naught, which is 0, I put it there. When j equals 1, I have t1, I put it there. Okay, so we know the j's and alphas. Now let me go and write the alphas for you. So here from n equals 2, Okay, so from this formula, so we said that we'll use this formula to find your y's. Okay, so from this formula as well, you know that f of x is equal to s squared. Okay, so this means that f of xi will be xi squared. Okay, so I just put those things inside this formula, which we'll use to find our y's. Okay, I put them here, and my lambda is -1, so I put -1 there. My g of x is x, so g I of xi will give me xi. Okay, so these are what I have here to find my y's. Now when n is equal to 2, means that lambda I are, so lambda naught is 1, lambda 1 is 4, lambda 2 is 1. Now why? Because I told you that when you write a Simpson's 1/3 rule, this time n is equal to 2. So it means that when I equals 0, I have f of x naught, which I'll pick the coefficient of f of s naught, and that is what? 1. So n equals 2 means that we have s naught, f of s naught to f of x2. Okay, the last one will be x2. Now when I equals 1, we have, we say n is equal to 2. This means that my I is equal to 0, 1, 2. Okay, with the 0, 1, 2, meaning I equals 0, I come and pick the coefficient here. I equals 1, I come to where I start from 1. Okay, and that is this side. I pick the 4. Now I is equal to 2. Yes, we have I equals 2 here, but I realize that 2 is the last one, the n. So you come to the last one, which is the fn, and the coefficient there is what? 1. Okay, so that will be my alphas. Okay, so I know my alpha naught is 1, alpha 1 is 4, alpha 2 is 2. Sorry, alpha 2 is 1 as well. So with this, we know our xi, our tj's. So all that we start with is just come and then put the values here, alpha j, tj, and we find our y's. Okay, so let's start. Now with the first one, you know that we said yi, okay, is given by xi squared, okay, minus xi into the summation. So I'm coming to sum everything. So when j is equal to 0, I have alpha naught, okay, from the formula I've written in the previous one. Okay, let me show you so that you can copy this. So from this formula, I'm just summing this side. Okay, it's a sum. So when j is equal to 0, I have alpha naught t naught y naught plus, and j equals 1, alpha 1 t1 y1. Okay, like that. So have alpha naught, let me write it well, alpha naught t naught y naught, okay, plus alpha 1 t1 y1 plus alpha 2 t2 y2 plus alpha 3 t, sorry, we don't have 3 there, sorry. So like that, and then you close them times your delta t, which is 1/6. I hope this is cool. So what I go ahead and do is just put your t naught and the rest inside. Okay, so from the table we had, okay, you know that our t naught is what? So from this table, we're coming to write a t naught, t1, and t2 inside, and then we will write alpha 1, alpha 2, and alpha naught inside as well. So t naught is 0, or alpha naught is what? 1 times t naught, which is 0, and times y naught, okay, and plus alpha 1, which is 4, times t1, which is half, times y1, plus alpha 2, which is 1, times t2, which is also 1, and y2. All of these times 1/6. Okay, just this side times 1/6. Okay, so this means that my yi is equal to xi squared minus xi into 0 times that, I get 0. So I have 4 times half, and that will give me 2y1. Okay, I have 2y1 plus y2 times 1 over 6. Okay, so this is turning to be a very simple one. Okay, I told you it's very, very simple. Just that if you don't know what to use, the formulas, the alphas and the tj's, then it becomes a problem. So if I multiply 1 over 6 throughout, I get 1 over 3 y1 plus 1 over 6 y2. So I'm done with the t's. In terms of the t's, I'm done. So we go to the xi's and put them here to find this. You see we have yi equals xi squared minus si. Okay, so we just go to the xi's or the I. So when I equals 0 at, let me write it that way. At I equals 0, I have my y naught to be equal to x naught squared, okay, minus x naught into 1 over 3 y1. Okay, let me write it well. y1, then plus 1 over 6 y2. And what is x naught? X naught is 0 from the table, so I have y naught being equal to x naught 0 squared minus 0 times this, so I have 0. Okay, so y naught is 0 now, and we are safe. So equation 1, let me name it like that. Then at x, y, or I equals 1, we have y1 being equal to x1 squared, okay, minus x1 into 1 over 3 y1 plus 1 over 6 y2. Now what is x1? x1 is half, okay, so I have y1 equals 1 over 4, half squared is 1 over 4, minus 1 over 2 into 1 over 3 y1 plus 1 over 6 y2. So let me continue from here. So we know that y1 is equal to where is mine? Okay, y1 is equal to 1 over 4 minus 1 over 6 y1 minus 1 over 12 y2. So y1 plus 1 over 6 y1, okay, is equal to, plus 1 over 12 y2 is equal to 1 over 4. So here the LCM here is 12, so I multiply through by 2. I have 12 y1 plus 2 y1, okay, plus y2 is equal to 3. I hope you understand this. So you add terms. I have 14 y1 plus y2 is equal to 3. I hope I'm cool here. Yes, and this will give me equation 2, okay. I have equation 2. Now at I equals 2, that's the last one, you have y2 being equal to x2 squared, okay, minus x2 into 1 over 3 y1 plus 1 over 6 y2, okay. So you go ahead and simplify this and realize that you have y2 being equal to x2 is 1, so squared minus 1 into 1 over 3 y1 plus 1 over 6, right, y2. So I have my y2 being equal to 1 minus 1 over 3 y1 plus 1 over, minus as well. Okay, minus 1 over 6 y2. So here y2, or let's say the LCM here is 6. Okay, so if I multiply through by 6, I have 6y2 is equal to 6 minus 2y1 minus y2. I just multiply through by 6, okay. So if I just send the y's to one side, I have 2y1 plus 7y2, okay, equals 6. Equation 3. I hope you get this. I realize that both equation 2 and 3, equation 2 is given by 14 y1 plus y2, I guess. Okay, plus y2 is equal to 3. That's equation 2. So realize that from equation 1, we know y not to be equal to 0. So with that, you don't touch it. But from equation 2 and 3, they both have y2 and y1 unknown. So what you are coming to do is just find them. Okay, so using or let's say from both equation 1 and 2, equations 2 and 3. Wow, I've written equation 1 here. From equation 2 and 3, in a matrix form, you know that we have 14, then 1, 2, 7, then y1, okay, y2 is equal to 3, 6. So you state the method you are using from Cramer's rule. Okay, from Cramer's rule, you know that y1 would then be equal to the determinant of 3, 6, 1, 7. I hope I'm cool. 3, 6, 1, 7 over the determinant of the main matrix, coefficient matrix, this one, okay, which will be equal to 15 to the determinant of that over determinant of that, and this is equal to 5 over 32. Okay, now you go to the next one, y2 then be equal to determinant of 14 to 3, 6. Okay, I hope you know how to use the Cramer's rule. The Cramer's rule, when you want to find the first one, just put the whole of this in here, and that will be your numerator. Okay, the determinant of that over the determinant of the main coefficient matrix. So with the y2, you pick that same side, this one. Okay, you pick this same side and come and put it here. Okay, and then that will be the numerator over the determinant of the main matrix or the main coefficient matrix. Sorry, let me change my background to black. Okay, I hope this is cool. So let's go ahead and simplify for the other one. So 14, 2, and this is 1, 7. Okay, now this determinant is given as 78 over 96. Okay, and this is equal to 13 over 16. So you know our y1, y0, and y2 now. So y0 is equal to 0, y1 is equal to 5 over 32, and y2 is equal to 13 over 16. So you know all these. So what will happen is we quote our formula back that y of x, okay, y of x is given by, in this question, is x squared minus x into the summation of j equals 0 to 2, because n is 2, so 0 to 2, then alpha j's, then tj, because h of tj is given by t. H of t is given by t, so if h of t was given by, let's say, t squared plus 1, then tj's will be just tj squared plus 1, and that will be all. Okay, so when it's tj, know when it is just as an expression or a single variable. Okay, so this then yj's delta t. So these are the yj's, the y0, y1, and y2, and know how to find them. Okay, so you're now coming to put them back here in our delta t, and then we are done. So the solution is given by y of x. Okay, y of x here is equal to x squared minus x. Then we put our values in. Okay, lambda not, or alpha not, sorry, then t not, y not. Okay, plus alpha 1 t1 y1 plus alpha 2 t2 y2. If you remember, in our previous formula, we stated that delta t is given. So let me write it here, 1 over 6. This is what I wrote. at the beginning. This is what I wrote. So alright, so with this, all of this side, okay, multiply by 1/6. So what you do is just pick your values and put them in. Y of x, okay, y of x is equal to s squared minus x into alpha naught is what? 1, t naught is 0, y naught is 0, and plus alpha 1 is what? 4, t1 is half, y1 is what? 5/32, okay, then plus alpha 2 is what? 1, t2 is 1, y2 is what? 13/16. All of these times 1/6. I hope you get this. So y of x is equal to s squared minus x into 4 times half will give me what? Just 2, okay, then times 5/32 plus 13/16, okay, then times 1/6, okay. So here I have my y of x equals s squared minus x into 2 times, that will give me 5/16 plus 13/16 into 1/6, okay. So this means that I will get something like this: y of x being equal to s squared, okay, s squared minus x into 18/16 times 1/6, okay, and 6 goes here 1 and goes here 3, so I have y of x being equal to s squared minus x into 3/16, which is the same as s squared minus 3x, okay, minus 3x/16. So realize that this is the same answer we had for iterative kernel and iterative free term. I mean the method of successive approximation to the free term and then the kernel. I hope you get this. So this is the answer when we use the Simpson's 1/3. So try this with so I said I'll try this with Simpson's 3/8, okay, and that with that, if you realize the delta t will give you 3/8 h, and you know h will be equal to, I say choose n for n equals 3, because n should be a multiple of that, so h will be then be equal to 1/3. It will be just 1 minus 0/3, okay. And then the alphas, let me give you a hint about the alphas. Okay, so you compare that, you realize that your alpha naught will be equal to 1, alpha 1, so it's n equals 0, 1, 2, and 3. Okay, so for alpha naught you get 1, alpha 3 you get 1, but these are what you just go and search for. Okay, so alpha 1 give you 3, alpha 2 give you 3 as well. Alpha 2 will give you 3 as well, and alpha 3 will give you 1, because alpha 3 is the last one, okay. So use this and make sure that you get the same answer, okay. So with that, I'm pretty sure that you get how do you call it, y naught to be the same as 0, but your y1, y2, y3, so that is what you find 3 values of y's, okay. So thank you, and don't forget to subscribe to my channel if you have not subscribed. Like my video and also comment and tell me if you're able to use a Simpson 3/8 to solve it, okay. See you next time.